Okay, so equal lang ako siya as x. Okay? Na-record na. Recorded, whiteboard, then share screen. Share screen. Whiteboard. Oops. Okay. So, yeah, so I have an atom machine, no? Nakoy atom machine with pulley, no? With pulley. This is M1 and then this is M2. Okay, so if the radius of pulley is A, then there will be this X1, which is just equal to my X. So this is X. And then if that is X, then X2 would be L minus pi A, the semicircle, so circumference of a semicircle, kaya wala man i-appealing sa taas, no? Minus X. In this case, your x2 and x1 are related to each other by this variable x. So that in that case, there will be only one degree of freedom, and the coordinates that we're going to use is this x. Okay? So na x1. So importante man ang x ang position, no? I have the x1 and I have the x2 there. So what will you get here is you can actually express the Lagrangian, which is equal to um, the kinetic energy and minus the potential energy, no? So what is the kinetic energy? Is the kinetic energy, dali lang, no? Kinetic energy is na ko'y duha ka buok. Kinetic energy on M1 and kinetic energy on M2. So I have 1/2 M1 velocity in terms of x. Okay, in terms of x1, the velocity will be x1 dot. Sakto ba? So na ko'y x1 dot plus for the M2 na siya kinetic energy nga M2 X2 dot quantity square. Okay? So we have two kinetic energies. Excuse ha kasi lang. So, okay, so nanakoy, take note I have two masses, okay? And I think appeal yeah, we include the pulley, no? We include the pulley, so therefore there are three there, sorry. I have kinetic energy for M1, I also have kinetic energy for M2, and I also have rotational kinetic energy for the pulley, no? So I have three terms for kinetic energy, and ang last term is for the rotational kinetic energy for the pulley. And if you recall, rotational kinetic energy is can be written as this: the moment of inertia times omega squared. So one half moment of inertia I. Okay, so this is the kinetic energy rotational. Okay, so it is equal to 1/2 times the rotational analog for mass is I, which is we call this one as moment of inertia, and omega is just angular velocity. In this case, you can write angular velocity as um, v over r, v over a, sorry. So v over a, so we have 1/2, we can write that as 1/2 I times v, which we call this one as x dot, okay, square over the radius. I think napako-square po sa akong radius because omega square mo na siya, no? Take note, omega is the angular velocity, and angular velocity can be written as the linear velocity over the radius. Okay, so over the radius. So we have 1/2 times I times x dot over a square. Okay, I is constant there. I is just the moment of inertia. Yeah, moment of inertia. Okay, I think define ako ni last time. I is the moment of inertia. Okay, moment of inertia. And again, omega is just angular velocity. It's just equal to velocity over the radius. Okay, the radius of the pulley is a, so that's why we have x dot over a quantity square. That's x dot square over a square. Okay, so first two terms are the translational kinetic energy of M1 and M2, while the last term is for the rotational kinetic energy of the pulley. So that's the kinetic energy of the system. How about the potential energy? The potential energy is just if we say this one is our ground, okay, if we let the pulley as our ground. Okay, this will be our ground. So therefore, as you can see, the potential energy is negative because below siya sa ground. So therefore, the velocity, the potential energy would be negative mass times the gravitational constant times the height kung asa na-locate imong M1. So in this case, M1 is located at x1. So we have minus M1 G times x1, okay, minus M2 M2G M2G times x2. Okay. But take note, there is this relationship between x1 and x2, right? x1 is just x, while x2 is equal to L minus pi a minus x. So, therefore, masulat na ko or ma-rewrite na ko si V as minus M1G times x minus M2G na ko L. Take note, L is constant minus pi a minus x. So in this case, si potential is just this, no? Minus m1gx minus m2g L minus pi a minus x. So in this case, as you can see, potential is just a function of x, okay? See, potential is just a function of x because m1, m2, g, L, and a are constants. So it is just a function of x, okay? So potential is a function of x. Now, how about this x1 dot and x2 dot? So what is x1 dot and x2 dot? I have ako na nabutan rin, no? Ako yung kinetic energy. Take note from here, x1 dot is just equal to x because x1 is equal to x if you take no, not x but x dot, sorry. So x1 dot is just x while x2 dot, as you can see here, is if you derive x2, if I derive x2, what unsa ako makuha? L is constant, pi a is also constant. If I derive x2, you will get minus x dot. Sakto? So na minus x dot. Okay. So minus x dot, yeah, that will be the x2 dot. So therefore, if I simplify the kinetic energy, I have 1 half m1 x dot square plus 1 half m2. This is also x dot square, sakto ba? This is also x dot square because if you take x2 dot square, you will get x dot square lang ihapon. Okay, so na ko yung minus m2, 1 half m2 x dot square plus 1 half I x dot square over a square. So this will be my kinetic energy. Okay? So for simple atom machine, my kinetic energy is equal to that. Okay. Now the Lagrangian is just combine the two. So the Lagrangian is equal to 1 half m1 x dot square plus 1 half m2 x dot square plus 1 half I x dot square over a square and then minus v. So, minus v man na siya, no? Minus v, tapos na ko minus m1gx minus m2gx, so mahimo siyang plus. So, na ko plus m1gx plus m2g L minus pi a minus x. Okay? So ba? m2g plus, no? Plus m2g L minus pi a minus x. Okay. So, if I combine similar terms, okay, I can rewrite L as 1 half. Combine akong similar term like x dot square. I combine 1 half m1 plus m2 plus I over a square x dot square. Sakto? Combine ako din sa duha. Tapos, na ako yung makuha nga m1 minus m2 gx. Sakto ba? Because of this. Combine ako ng m1 gx o m2 gx. Okay? So, na ako ingana, no? Minus m2 gx. Plus, ang nabilin is na ako m2g which is constant, L minus pi times a. Okay? So, ba? m2 gl minus g L minus pi a. Okay, so this is the Lagrangian of my system. Notice if we will not consider the pulley, ang mawala lang is actually ang mawala lang is this pi a and the I over a square. Okay, the third term and the last term of your Lagrangian. If I will not include the pulley. Now, this is the Lagrangian, and take note only one coordinate, generalized coordinate. Okay, coordinate. This is with respect to x lang. So therefore, I have the Euler Lagrange, which is equal to this d dt of partial L partial x dot equal to 0. If I use this, what will happen na kung partial L with respect to x is equal to what? Na kung partial L with respect to x is equal to, kung i-derive na ko siya with respect to x, kanila ang mabili, no? Kanila ako i-derive, okay? Kanila ako i-derive, so I have m1 minus m2g. m1 minus m2g, while my partial L with respect to x dot, pila akong partial L with respect to x dot, kanino? Kanina ako i-derive, wala ang 1 half. So, only x dot ang mabilin. So, na ako'y m1 plus m2 plus the moment of inertia over r square or the radius square x dot. Tama ba? Okay. So, therefore, the d dt of this partial L partial x dot is equal to m1 plus m2 plus I over a square x double dot. Such that the equation of motion now, the equation of motion is if you combine the two, you will get m1 minus m2g, okay, equal to minus m1 plus m2 plus I over a square x double dot equal to 0. So this will be the equation of motion for atwood machine, considering atwood machine um, with pulley, no? In which we did not neglect the pulley. Okay? If you solve for acceleration, and I think familiar ninyo ni, no? Familiar mo aning kaning nga term, pagdamdo mo sa unas ang atong atong machine, no? If you solve for acceleration, what will you get? The x double dot is just equal to, if I divide both sides by m1 plus m2 plus I over a square, you will get the acceleration, which is equal to m1 minus m2g all over m1 plus m2 plus I over a square. Aha. If there is no pulley, what will happen? Without pulley, what is the acceleration? Kani may familiar sa to, ano? The acceleration using Newtonian mechanics for simple atwood machine is equal to this one. Without pulley, meaning I is equal to 0, okay? When I is equal to 0, it will reduce to the simple atwood machine. Atong simple atwood machine natong the acceleration would be equal to m1 minus m2g over m1 plus m2. Okay? Kung apilan ni ko siya og pulley and then I will use Newtonian mechanics, maglisod ta og lisod siya kuhaan og acceleration. Okay? But with or using Lagrangian mechanics, makuha na to ang equation of motion for a simple atwood machine with pulley, which is equal to this one. I have the acceleration equal to that, and then if I set I equals 0, meaning you will neglect the pulley, then it will reduce to the acceleration of a simple atwood machine, which is equal to this one. No? Familiar equation na to, no? Yeah, atong familiar equation na ko last time. Okay, so that's for the atwood machine. Okay, let's go to double atwood machine. Okay, so nagkalisod na sa, no? Kalisod na ba sa? Uh, hmm, ano pa ang double atwood? Sino ako? Pa rin ako mag-drawing, no? Double atwood machine. So, this is for double atwood machine. Oops. Double atwood machine. So, calculate calculate the equation of motion for double atom machine. So this is double atom machine. Hmm, ipasa na ko ang figure double atom machine. Pwede na ako i-drawing. Hmm. Kanino? Ini ang double atom machine. Okay. Paste na ako dire, no? Oops. So this is double atom machine. I have three masses. But in this case, I will neglect the pulley. Okay? I-neglect na lang ako ang pulley. Okay ra? Kasi sa inyo exam kaya na ay pulley. So, please study this one. Ito po ko sure, no? So, what if i-apply na ko ang pulley? What will be the equation of motion? So, in this case, in my example, simple example, I have a double atom machine. I have three masses, M1, M2, M3, attached to strings. The length is L and L prime. So, the length of this one is L. Ang length sa imong string is L here. And then, the length of this one is L prime. Okay? So, this is L prime. Okay? So, and then we assume, again, that in this case, no, in this example, assume pulleys, pulleys man, no, are massless. Okay? Are massless. So, sa inyong exam, basing dili siya massless, no? Sa inyong exam, basing hindi siya massless. So, please, prepare lang, no? I-prepare lang, no? So, what if i-consider na kung na-radius ang imong pulley, kani A, tapos B na siya or what, then what will be the equation of motion? Anyways, kanilang no, assume that pulleys are massless. Pulleys are massless. Okay. So calculate what is the equation of motion. Okay. Equation of motion. So dali ra ni siya, no? Okay. First thing to do is you will there are pila ka buok um, um, degrees of freedom. There are three masses, so I have 9 degrees of freedom, but na ako'y constraints nga 1 to 6, 8, no? Na, ano to? 8? 8 man eh? O, dili. Na ako'y 9 degrees of freedom, pero I have, I think 7 ka constraints. Okay, na ako'y 7 ka constraints. So, therefore, there are 2 degrees of freedom here na ako ang i-consider the x and the x prime. Okay? So, na ako'y pila ka book degrees of freedom, na ako'y isa, and then na ako'y x prime. Okay? So, I have 2 degrees of freedom, x and x prime. So, if the length here, the location of my M1 is x, okay? If the location of my M1 is x, then the location of the second pulley must be equal to L minus x. Okay? Nakuha ninyo? So, if the location of my M1 is x, then the length, take note, length, ang first string nakuha sa length of L. So, therefore, ang first location sa ako ang second pulley will be L minus x. Okay? So, therefore, if this is L minus x, then this would be the location of M2 is x prime, okay? The location of x2 is x prime. Then M3 is just equal to L minus x prime, L prime minus x prime, okay? So take note of the distances, okay? Take note of the distances. Ako lang i-resolve para maklaro, no? So if this is x, then second pulley is located at L minus x, okay? If this is x prime, then M3 is located at L prime minus x prime. Okay, take note. Because the length of the second string is L prime, while the length of the first string is L. Okay, so take note of the distances. This one is L prime minus x prime. This one is L prime minus x prime. This is L minus x. This is x prime. M2 is located x prime below the second pulley, while M1 is located x below the first pulley. Okay, so nakoy ingani nga mga locations. So as you can see, the location of M1 is just x. How about the location of my M2? Kung sa akong location ni M2? The location of my M2 is I have um, L minus, kung lantawan mo, gikan diri, no? Gikan diri, oops. Gikan diri, padulong ni M2, okay? Padulong ni M2. Kana, pila na siya? That's equal to L minus X plus X prime. Sakto? Tama ba? Ang location from, suppose this is our ground, okay? Suppose this is our ground. The location below the ground of M2 is actually equal to L minus X. Na ko L minus X daan plus the X prime. Okay? And for M3, si M3 karon kani nga distance. Pila na siya nga distance karon. Kana nga distance is equal to na ko L minus X plus L prime minus X prime. Okay? Take note, L and L prime are not the same. Okay? Lain na siya nga length sa akong string. Okay? So, I have L minus X plus L prime minus X prime. Okay. So, nana ko tulo ka position, no? Nana ko tulo ka position. I will let that one as, ilet na ko siya as X1, which is equal to X. X2, the location of your M2, which is equal to L minus X plus X prime. Okay? If you do the derivatives, X1 dot is just equal to X dot. Okay? If you do the derivative of X2, nakoy duha, no? Nakoy minus X dot plus X prime prime dot. Sakto ba? And then while my M3, location of M3, which I call that one as X3, nakoy L minus X plus L prime minus X prime. And if you do the derivatives, x3 dot is equal to minus x dot minus x prime dot. Okay, so these are the positions and velocities. Okay, x1, x2, x3 are positions of m1, m2, m3 respectively, while x1 dot, x2 dot, and x3 dot are the velocities of these three masses. Sakto ba? Igora na ko i-derive ang x2, no? Ano ko minus x dot, sakto na, no? Plus x1, okay? x3, i-derive na mo x3. L is constant, so 0 ang iyahang derivative. So, x minus x dot minus x dot prime. Aha. So, therefore, I have all the positions and all the velocities I can get now. I can solve or I can express kinetic energy equal to this. 1 half m1 x1 dot square plus 1 half m2 x2 dot square plus the last one is 1 half m3 x3 dot square. Again, I did not include the pulley. So kung nana siya pulley dira karon, you have to include the rotational kinetic energy due to that pulley. Okay? So nakoy duha ka pulley. So napo kay duha ka ma-add nga terms ay ako ang kinetic energy. So T is equal to, in terms of x and x prime, I have m1x that square plus 1 half m2 x2 ang sa akong x2 nako minus x dot plus x prime dot quantity square plus the last one is 1 half m3 x3 is minus x dot minus minus x dot prime quantity square. Again, I have two degrees of freedom. I have two generalized coordinates, the x and the x prime. Okay, the x and the x prime. So we have that 1 half mx minus, okay, tama. Tapos ka na, minus, okay. So if I simplify this further, we have 1 half m1x dot square plus, kani siya, no? m2, may mo siyang pinana. Ako x dot square minus 2x dot prime plus x dot prime square plus 1 half m3 x dot square plus 2x dot prime plus x dot prime square. Sakto ba? Tama na no? So, yeah, we have that. Sakto na 1 minus x dot minus 2x x dot plus x dot square x dot plus 2x x prime x squared plus, oh yeah, that's the kinetic energy. How about the potential energy? Potential energy is just if your ground is above the masses, we have negative m1 gx1 minus m2 gx2 minus m3 gx3. So if you simplify this, we have m1gx minus m2g. My x2 is L minus x plus x prime minus, minus m3g x3 is L minus x plus L prime minus x prime. Okay, so I have the V, I also have the T. Masolve na ko or ma-express na ko si Lagrangian, which is just equal to T minus V. Okay, T minus V, T i-substitute na ko akong T ug akong V sa L. Then, I have two Lagrange equation. Tama ba? I have two Lagrange equation. The partial L with respect to x minus d dt of the partial L with respect to x dot equal to 0. And for the second one, I have partial of x prime minus d dt of partial x dot prime equal to 0. So I have makuha ko um duha ka equation. And this will be your assignment, no? This will be your assignment. So di na ako ni-derive. Taas-taas yan, no? Pero this for your practice, no? For your practice, if you derive the L with respect to x, if you derive the L with respect to x dot d dt, derive with respect to x prime, derive with respect to x dot prime, you will get this equation of motion. So this will be your assignment again. Please derive. Again, gihatag na nako ang Lagrangian, no? Gihatag na ang kinetic energy for double attitude machine. Gihatag ko na ang potential energy. So, combine mo siya, makuha mo ang Lagrangian, and do the Lagrange equation of motion, you will get these two equations of motion. So, the equations of motion for derive, no? Derive the equations of motion for double Atwood machine. Okay, double Atwood machine. Okay. So again, this will be your assignment. So please derive the Lagrangian. Okay. Using the two Lagrange equations, makuha na ko ni isa ka makuha na ko ning duha ka equation of motion, which is given by this m1 x double dot na plus m2 x double dot minus x double dot prime plus m3 x double dot plus x double dot prime equal to m1 minus m2 minus m3 times g. Okay, so m1 x dot, again, derive the Lagrangian, and what will you get is this equation of motion m1 x dot m2 x double dot, okay, plus was m1 m2 m3. Then the second one with respect to x prime, okay, katong isa ka Euler Lagrange nga gamiton, okay, m2 minus x double dot plus x double dot prime plus m3 x double dot plus x double dot prime equal to m2 minus m times g. Okay? M3 x double dot x. Okay. So this will be your assignment. Again, ako na po na ibutang daan na kasi pala. Okay, wait. Oops. Okay, so para makasave tag oras po, no? Please answer this. So, ang nakakunindot lang, kinanay Lagrangian daan, no? So, kung nanay Lagrangian daan, may problema, no? May problema ko nanay Lagrangian. Igo naman ka mong derive tayo. Okay? So, yeah. Okay. Then, okay, force, force, nagtuwa paso. Juben. Juben, di lang yung tigpasahan si Juben, no? Si Juben? Juben. Wala si Juben. Ano? Due on Wednesday. Okay? Okay. So that will be your assignment. Again, the equation of motion for um, double atom machine. Okay? So, sa libro, gidiretso na na, no? I have two Euler Lagrange, pero gidiretso niya hatag ang equation of motion. Please provide the missing calculations. Okay? So that will be your assignment. Kabalo mo mabumulatek class? Kabalo mo mulatek?
Dili, sir.
Hindi ko mo kabalo mo. Lang. Okay. Any question?
Wala, sir.
Okay. So let's proceed, no? Let's proceed to another example. Hapit na ba atong i-exam, no? Another example, we have this particle sliding on movable inclined plane. Okay? So another example, taon na, ang ako ang problem is na lang ko yung object tapos gipa slide lang mo siya in an inclined plane, no? Karon gidungagan nato, no? Ang una, ang primero na nga example, pinaka-simple na example is na lang ko yung mass, tapos ipa-slide din mo sa dira. Then, you can calculate the equation of motion. You can solve for A, which is equal to G sine of theta. Okay, I think nag-remember mo na, no? Nag-remember mo na. The acceleration of this object is equal to G sine of theta. Now, in this case, dili lang ang particle ang naglihok, okay? So, nag-move imong particle pa-slide pag paubos, dili lang siya ang naglihok, but also the inclined plane. Okay, so we have this particle sliding on a movable inclined plane. So, na-object to read, it is nag-slide sa padulong sa ubos, at the same time, frictionless ang imong gari. Okay, frictionless ang imong gari. So, pag mulihok ng object dire, what will happen to your inclined plane, since there is no friction here, what will happen to your inclined plane? Your inclined plane will also move to that direction. Okay, so nga na ang resulta, no? Nag-slide ang imuhang object at the same time, nilihok po ang imong inclined plane going to the right. Okay, so that's the setup. So we have a particle of mass m free to slide along a smooth inclined plane, meaning there's no friction. Okay, meaning there's no friction, and there are only 2 degrees of freedom. The inclined plane is not fixed, and it is free to slide along a smooth horizontal surface. Since wala friction gari, no? So, free to slide lang siya. Because of this object M, mo slide ko na mo inclined plane. The mass of inclined plane is big letter M. Take note, di ko maklaro, no? The mass of this is big letter M. While ang imong particle has a mass of small letter M. Okay? In this case, there are only 2 degrees of freedom because I have 6, no? Original na akong degrees of freedom is na ako 6, but na ako upat ka holonomic constraints. Okay? I have for inclined plane na ako y equals 0, z equals 0, and for the mass particle m kaning gamay is I have kaning siya, and z equals 0, no? So kaning nga constraint and the z equals 0. I think this is y equals theta ba ni? Yeah, this is theta, so na ko uh, sin theta over cosine theta nga term, okay, for your holonomic constraint of that. So I have 2 degrees of freedom. Okay? So the only coordinates na independent to each other is the x prime and the x. Okay? So question is, what will be the equation of motion of this system here? Okay? This, as you can see, um, the positions, take note, are nakoy x prime going there. Okay, nakoy x prime going there. And then I have x nga padulong dira, tama ba? So inclined plane is going to the right, while si x prime is going paubos na with some angle theta. I think this is theta here. Okay? If you want to get the velocities, very simple. Nako ingan nga figure here. Okay? Nako x dot. This is for horizontal motion. The velocity is x dot. While the motion of your mass m nga gamay is x dot prime. Okay? That's that if you do the vector sum, you will get this triangle, and the relationship between x and x dot and x prime is equal to v, which is equal to x dot vector x dot plus vector x dot prime. Okay, so what's the Lagrangian of this system? First, I will get the Lagrangian is equal to t minus v. So I have kinetic energy, I have 2, tama, nakoy duha, nakoy first is 1/2. For the inclined plane with mass big M, we have m x dot square. So walay problema sa kaning M kay translational horizontal lang man ang motion. So the velocity is x dot only. So therefore the kinetic energy is 1/2 m x dot square. Okay. What about for small particle m? For small particle m, ako'y 1/2 m. What's the velocity? Kung sa akong velocity ni wali. Kung sa velocity na ako ni small particle m, this is equal to this x dot square plus x dot prime square minus plus 2x x prime cosine of theta. Asa man yung meter karon? Gikan siya sa, take note, this is a vector, right? You can actually write v, okay, as x dot vector x dot plus vector x dot prime. So, if you do that product, what will you get? Okay, x dot square plus x dot prime square plus nakoy 2x, sakto ba? I-try na to na, nakoy oops. Vectorically, my v is actually equal to this, right? X dot plus vector x dot plus vector x dot prime. Okay? If you do a dot product of itself, okay, so now if v dot v, ako v dot v, ako v dot v, vector v is just equal to this, right? X dot plus x dot prime dotted with x dot plus x dot prime, which is equal to x dot square plus x dot prime square plus 2x dot product of x dot prime, which is by definition the x dot prime is equal to x prime cosine of theta. Sakto? X prime cosine of theta. So that's why na ko cosine of theta. Okay? So yeah, that's the velocity of my particle 1. Okay? Take note, dili lang sa x dot yung velocity, no? Kaya na pa man ko'y mulihok mo sa translation ni going there. Your M1, your M nga gamay. Okay? So that's why it's a combination between the velocity x and the velocity of x dot. Velocity x dot and the velocity x dot y. Okay, so that's the velocity of my uh, small letter m. Okay, small letter m. Saan man ito? Yeah, that's the velocity. While the potential energy is equal to, it's just equal to minus m g x prime sine of theta. So, because if this is the ground, may akong ground, then my inclined plane has potential energy equal to zero. Okay, my inclined plane has potential energy equal to zero. So, ang naalay potential energy is the mass m, which is located at, it is located at x sine, tama? If you do trigonometry, SOHCAHTOA, the position of your mass m is just equal to x prime sine of theta. So that's why na x prime sine of theta there. Okay? So that's the potential energy. Oh, minus. That's dapat plus. Ayo, yeah, sorry. Hmm. Yeah. Consider niya na ang origin is here. Okay, so dire ang origin. There's no potential of the inclined plane because wala si height, no? Si M is wala si height. So consider mo si M as assuming na wala si height, no? From the ground. So therefore zero yung potential energy while the particle M, kaning gamay nga M, has a potential energy equal to minus mg x prime sine. So therefore the L is equal to this, combine na ako, no? T minus B na ko 1 half m x dot plus 1 half m x dot square plus x dot prime square plus 2x x dot prime cosine of theta plus mg x prime sine of theta. So if you derive, nakoy duha, no? Sa Euler Lagrange, um, nakoy duha ka Euler Lagrange. I have Euler Lagrange na x minus d dt of partial L partial x dot equal to 0. So if I derive x, so x ako i-derive, so say mo ko lang ko. Ako'y, x lang ako i-derive, may x lang. Wala, no? I think wala. Zero na siguro na eh. Zero ba na? Yes? Zero ba siya?
Nag-click na siya. Sorry, sir. Sorry.
Okay. Zero ba siya? Kung i-derive na ko ang L with respect to x, wala. Zero, no? Zero, this is zero. And then, I derive the L with respect to x dot. Kani? So, na ko i-duha ka book. Mx double dot. So, I have the dt of mx dot. Okay? Tapos, kani, isa pa, na ko isa. Na ko mx dot. Okay? And then, isa. Kani, no? Kani. So, na ko 2 times 1 half is 1. So, na ko m x dot cosine of theta. Okay? Plus m x dot prime cosine of theta which is equal to 0. In this case, you have you have this d dt of pwede lang ko dito sa mga lang yan. I can factor out the m. Ako yung mx dot plus x dot prime prime cosine of theta plus big letter m x dot equal to 0. Okay? So, tapos, yeah, that's for the equation of motion for if we do the Lagrange equation with respect to x. Okay? So, this one must be constant. Okay? Para kuha na ito nga, if the derivative is 0, then this must be constant. Okay? This must be constant. That's fine. Cosine of theta plus mx dot must be constant. Okay? because derivative of a constant is equal to 0. Now, with respect to x prime, now for partial L, with respect to x prime, no? Okay, dt of my partial L with respect to x prime dot equal to 0. This one is not 0. Now, partial L with respect to x prime is not 0 because your potential is with respect to x prime. So, na ko'y mg sine theta. Tama? Na ko'y minus mg sine of theta minus ddt of this derive na ko ang x prime dot. So, na ko'y walang kabuok m um, x dot to mx dot cosine theta. Okay? Ako'y ddt of m x dot prime plus m x dot cosine of theta equal to 0. In this case, you can cancel out the m. Cancel out na akong m. So, therefore, okay, this is plus. Plus naman isa, no? Because this is plus, no? So, this is the derivative of L with respect to x prime must be plus here. So, therefore, ddt of x dot prime plus x dot cosine of theta equal to g sine of theta. Okay? And yeah, so this will be the okay naman, no? This will be the equation that we get from this Euler-Lagrange. And then, itong isa ka Euler-Lagrange, we can get this constant function equal. Okay? So, next time, so, paano na ko yung acceleration? Acceleration x dot double dot o acceleration x double dot prime. Okay? X double dot prime. And then, we will go to itong example na itong kaning next meeting. Do, sana, so, ina na, so, na po, pendulum dira. Okay? This one is moving there, and then this one is the lihok pa doon dira. So, what will be the equation of motion? Fix mo inclined plane, okay? Fix ako inclined plane, ha? Fix ko siya. Dili na siya mulihok, no? Dili siya mulihok. So, what if na po ingana, no? Pendulum na po nag-slide, tapos mumove pa gini, no? Mag-lisod na tama. Yeah. Check, try na to niya po. But, wala lang, no? Although taas siya, taas yung solution, but if you have the Lagrangian, uh, correct Lagrangian, you can actually get the equation of motion using Euler-Lagrange. Okay. Ay,